What we have here is a standard, what we would call bench grinder. We will see these in various different sizes. They can have different types of wheels on them, whether it's a grinding wheel or a buffing wheel or a wire wheel. So first thing we're going to talk about is some different names of the components of the grinder. So right here we have some shields. Inside these shields here we have lights, so we can shed some light on our working area. These areas here is called the tool rest. And yes, we can make adjustments to these to move them closer or further away from the grinding wheels. This particular grinder has two wheels on it. One is more coarse than the other. Naturally, the one that is more coarse is going to remove material faster. So, depending on what you're grinding and what your purposes is, would help you in wheel selection. It's standard on-off or start-stop buttons here. Quite simple. One thing we're going to want to make sure when we first walk up to the grinder is, does it look like it is ready to be used? Does it look safe? Is there maybe an extension cord wrapped around this thing? Maybe somebody picked an extension cord up and they put it over this. Well, that should be an indication to us that, hey, we need to remove that. That's not supposed to be there. Is there a part hanging off of it? Has this fallen off? Or is something out of an adjustment? Okay? So those are things we want to be aware of. So, once again, this is a one-person tool. We don't need a large group around here. We're not going to have a person running something off this wheel and a separate person running something off this wheel. This is a one-person tool at all times. The biggest thing I see with students is one person will be doing the work, and then all of a sudden your buddy's over here standing here like this and another one's talking to them. They're not paying attention. If you are the person running the tool, it is your responsibility to make sure that your area is safe before you start this tool up. Okay? So if someone's too close, you need to say, hey, you need to step back or get out of the way. I need to use this tool. We don't want anybody getting hurt with it. So, once again, once we've determined that the tool is safe and ready for use, we're going to turn it on. Prior to turning it on, though, we need to make sure that we are ready to use it. Meaning, I see some hooded sweatshirts in here. You have strings hanging off of those. We don't want strings getting caught in here. Jewelry, necklaces, anything that can get caught in here. If you're a person that has longer hair, you do not want your hair getting caught in this machine. It has a very strong motor on it. It's not going to stop. It'll pull that stuff right in there. Even loose clothing. Maybe you're wearing a shirt that has sleeves on it and it's loose. Gloves. We wouldn't want gloves that are going to be too loose. Okay? Gloves are a good idea, but if they're too loose on you, they could get caught in the grinder. So these are things we need to be aware of. Once we determine that the machine is safe for use and we're ready to use it, we can turn it on. We're going to turn it on and let it get up to full speed. Right as we turn it on, we're going to step off to the side and let it get up to full speed. Why are we stepping off to the side? Yes. Yes. If there was damage to one of these wheels, maybe something has hit it, it's cracked. Once it gets up to speed, they could explode and send debris everywhere. So we want to let them get up to speed. We don't want to be in the way of that. Another reason that we let it get up to speed is possibly something stuck down inside there. Something got in there. Someone was using this and threw a piece of metal in there, various different things. We don't want projectiles coming out of there and getting us. So we're giving a moment to get fully up to speed. And then we can grind whatever we're going to grind. We're going to rest whatever we're grinding on the tool rest and grind until we determine that we've accomplished the task at hand. When we're done with it, simply shut it off. We are not going to stick anything into the grinder to slow it down faster. Also, we do not grind on the side of the grinding wheels, we grind on the face of the grinding wheels. You'll notice right here, there's a couple of notes on this one. It says iron and steel only, no aluminum, brass, copper, die-cast, lead, or zinc. Who can tell me the difference between a ferrous and non-ferrous metal? Anybody? Yes.
Hardness of it?
Yes, ferrous metals are typically harder than non-ferrous metals. What else? Ferrous metals are using magnetic, meaning a magnet will stick to them. Also, ferrous metals typically, when grinding on them, will spark. Our softer metals typically don't spark. They typically are not magnetic. The reason I say no non-ferrous metals, they will fill the grinding wheel. Example would be aluminum. You're grinding something that's aluminum, it will fill this wheel, the voids in this wheel, and it's not going to cut as well. So we do not put non-ferrous metals on the grinders. Any questions on grinder usage?